Everyone. I'm very glad to have the opportunity of making this presentation today. I'm Boyan from Zhejiang University. This paper was done by my collaborators from the Australian National University, Monash University, and the Tencent AI Lab. The subject of our paper is detecting visual design smells in Android GUI against design guidelines. My presentation is in three parts. Firstly is our definition and motivation. I'm sure that some of you have noticed the concept of visual design smell in the title. We all know that code smells indicate violations of good software design guidelines. Visual design smell, also known as UI design smells, violate good UI design guidelines. I will illustrate these concepts with a few examples. Now, please select the better GUI in the following examples. The first example is a pair of dictionary app. For most people, the right GUI is better. Maybe you would say, I like the left one, it's colorful. It's okay, everyone has his hobby horse. The design itself is subjective, but for more people, two colorful navigation bars will distract users to find the functions they need. In contrast, the right GUI is better. In addition to visual design, GUI also includes motion and interaction. Just like when a card displays information, which one is better? Also, the right one is better. Expanding a card to reveal information is better than flipping over because expanding is more continuous. Besides, accessible information architecture is also important. People need to find the key information from the screen at a glance. The third example is a pair of travel apps. For most people, the right GUI is better. Users can get their travel schedule clearly from the right GUI, while the left GUI hides the information in top bar. It's a waste of time if a traveler is in a hurry. As I said at the beginning, UI design smells violate UI design guidelines. Design guidelines make up the design systems and guide the GUI design for various products, platforms, and services. In this work, we use Google Material Design as a case study of design systems. Take a look at these examples. Material design uses pairs of do and don't examples to reveal certain guidelines. If you compare these guidelines with the examples above, you would find that following these guidelines will lead to better GUI design. The second part is our approach. Our approach consists of three main parts. Firstly, constructing knowledge base of design guidelines from material design. Secondly, parsing input UI data and extract atomic UI info. Thirdly, validating guidelines to detect UI design smell and generate report. Before we turn to the details of our approach, I'd like to share the results of our demographic study of visual guidelines in material design documents. This is also the knowledge base of our approach. We examine three perspectives of guidelines in material design. They are component type, design aspect, and design dimension. The bar chart shows the distribution of guidelines by component type, like floating action button, banner, and so on. The two pie charts show the distribution by component design aspects and design dimensions. After constructing knowledge base of UI design guidelines, our approach starts to process input UI design image. The input image may come from two sources, a UI mockup created in design tools, or GUI builders and a screenshot taken by UI testing framework. Then we are concerned with 5 types of metadata, including component type, bounding box, the number of component instances, composition hierarchy, and text content. Since we have the input data and guidelines, we need to validate whether the input data violates the guidelines. So we summarize the required information of guidelines into 4 atomic UI information. They are typography, age, iconography, and color. The typography extractor aims to recognize text content. Iconography extractor detects the icons and images. The color aims to identify primary color, and the edge extractor aims to detect the number of edges and divider lines. For each component in the input UI, the validator firstly retrieves the relevant guidelines by component type from the knowledge base. Then it enters the relevant atomic UI information of the primary component and other related components into the guidelines violation condition. If the condition is satisfied, the input design are marked violated and are archived into knowledge base. After validating all UI components in the input UI, the validator produces a UI design smell report like the graph shows. Components may have multiple guideline violations. The report will summarize a list and highlight the violation box. Then the evaluation part. We conduct 2 experiments to investigate the detection accuracy of UIS-Hunter on the real app UIs from the RICO dataset and the UI mockups from the Figma design kit. After pre-processing the dataset, we apply UIS-Hunter to 11 types of components in about 61,000 apps. We manually check all reported violations, but we still have 51,000 UIs don't report any violations. It requires much effort to identify each UIs, so we adopt a statistical sampling method to sample and examine whether there are missing violations. Finally, we get about 7,500 UIs for 45 guidelines of 10 types of components. The details can be found in our paper. As to accuracy for mockups, we download the Material Design Kit from Figma, which is a popular web-based UI design tool. We adopt our tool in about 400 mockups and get 0.95 F1 score. Having confirmed the high precision and recall of our tool, we want to further investigate the utility of automated UI design smell detection from 2 aspects. Firstly, we want to contrast the manual effectiveness with our tool. So we select front-end developers examining 40 UIs, among which 27 UIs with violations. Workers are asked to review the 18 guidelines and independently identify violations. Developers don't know which UIs are violated and which guidelines have how many instances or may not have violations. They complete in 50 to 80 minutes. The results show that manual detection of UI design smells is less effective than automated detection. Especially people need to integrate multiple pieces of UI information. Secondly, we want to investigate how app users think of the UI design smells reported by our tool. So we use the 27 violations examples in the first user study and let users rate them by 5-point liked scale. The results show that 15 of 18 guidelines have more severe ratings, while 7 guidelines have close non-severe versus severe ratings ratios.
Hello again. Now we have the session for to ask about the paper. Don't do that. Hunting down visual design smells in complex use against design guidelines. The author is Bo Yang, that is here to answer your questions. So the first question from the attendees is how can we access the tool? Will the tool be made available in some form?
Hi everyone. The UI design is subjective, but we still need some specifications for our vast variety of products, platforms, and services. So the UI design guidelines was composed by design experts, and the guidelines constitute the so-called design systems, and to specificate to specification the guidelines for many UI designs. And I can see the second question, how to measure the severity of UI design smells. I think the two questions has some similarity, because the material design will give the severity of certain design guidelines, like warning and it says don't do that, just like our title shows. Uh, the material design webpage will tell you some guidelines is don't do. It means it will affect the whole UI design, or affect the user experience. And for some guidelines, it will tell you caution. It means you may need to think over about the UI design, but not saying your UI design is the fault. Just like our coders may meet error and warning in our coding. So
Okay.
yeah,
We have
yeah.
another question is how did you formulate the UI design constraint for the knowledge database? Did you answer
Yeah.
it? Or?
Yeah. I can see it.
Okay.
Uh, the UI design constraints, actually, we firstly extract the UI design guidelines from our from the material design guidelines webpage, and we formulate them as first order logic, as a validator, and we define the four autumn UI informations of input UI image. So the first order logic just to check if the if the four atomic information meets the logic, and it will test you is a conformance or violation UI design. Yeah.
Okay, we have another one is how can your tool help the front-end developers?
Sorry.
Yes, your tool is it useful for helping the front-end developers?
Yeah. We have released our tool as the web app demo. It is also accepted as the demo paper in ICSI. It names UIS-Hunter. The web demo allows users to detect design smells on their own UI data. And the users can refer to our collected guidelines of material design with corresponding conformance and violation UI design examples. And also welcome come to our demo presentation. It will introduce the usage of our tool demo. And in the future, we also want to package our tool as a library and provide interface allow developers, to allow from front-end developers to detect design smells on without back and severe processing. Yeah.
Okay. Another question is, what is the difference of a user interface design smell and a bad taste graphical user interface? I think that many aspects of the graphical user interface are subjective, and what one you prefers, maybe other don't like. So, what is the difference between design smell and a bad taste for you?
Yeah, you mean someone like UI design and the other one don't like the UI design, right? Yeah, as I said before, the design systems are composed by experts, and it actually we can't avoid the phenomenon you said from the source, because the UI design itself is subjective. So we but for developers we can't suppose each developers have enough uh, effort to design UI to design a UI to design an app for most users. So we need design systems to give specifications and give general specifications to follow. So, the guidelines is in the web page and in documentations. So our tool is automated. Is an automated tool to detect if the UI violates the design guidelines.
Okay. Another question is about how did you measure the severity of UI design smells? Did you use any questionnaire, or what kind of questions did you use for measuring severity?
Yeah. The material design actually gives the severity of certain design guidelines, but we also conduct uh, conduct a user study to evaluate the utility of our tool, and we want to know how the real app users rate the severity of UI design smells reported by our tool, and the results shows the results the results the results shows this about over 50% of users and guidelines are rate. Besides, we use five liked scale to evaluate the severity of our of UI violations, and over 50% of UI design have higher 4 to 5 rate ratios.
Okay, we don't have time for more. If any other attendee has more questions, you can go to the discussion room automatically after finishing this session. So receive a virtual clap
Yeah,
and
thank
very
you.
excellent job. Thank you.
Yeah, thank you. Thank you, everyone.